Hello and welcome to this video brought to you by Smart Edu Hub Mumbai. In today's video, I shall teach you how to find the period of a simple pendulum. Now, do you know the meaning of a simple pendulum? Well, simple pendulum is an object suspended by a string and it keeps oscillating. Okay, now once the meaning of the simple pendulum is clear, now do you know the meaning of period? Because since you are going to learn to calculate the period of a simple pendulum. Now, period means the time taken to complete one oscillation. So now, let me show you the meaning of the term period by oscillating this pendulum. Now, there are certain things you should keep in mind. For example, if you look just below the pendulum, there is a line, a dotted line in blue, right? Now, that line is my reference point, meaning when I start calculating my oscillations, I will start counting only when the pendulum crosses this point for the first time as the beginning of the oscillation, and when it crosses for the last time as the end of its oscillation. Now, let me show you with the help of an example, and what I can do is I'll trace the path for you. Okay, tracing the path meaning you will come to know when is the oscillation beginning, and when the blue line stops repeating itself, it means that the oscillation has come to an end. Okay, now also there are two modes of this oscillation. One is the normal mode and one is the slow mode. Now I'm going to oscillate the pendulum in a slow mode so that you are able to understand the meaning of the oscillation properly. As you can see, while I'm taking this pendulum up, there is a angular calibration happening, and that is showing me now it is 60 degrees. So the angle of oscillation is 60. Now what I'm going to do is I'm going to release this. Okay, I'm not going to time the oscillation. The idea is only to make you understand what an oscillation is. There, the blue line tells you the oscillation has begun. Okay, half an oscillation completed. And now one oscillation complete. So if you can see, the line got disconnected once it touched the point of reference or the line of reference, meaning from the line of reference it first went left up, it completed an entire journey like a smiley from left up to entire right up, and from the right up it came back to the reference line. That is, this much journey is said to be one oscillation, right? Okay, now let me show you how fast is a normal oscillation. I'm putting the normal mode and here I'm oscillating. I'm taking 60 so that it's easy for me to keep in mind, because when I'm taking multiple oscillations I need to keep a fair angle, right? So 60 is easier for me to remember. I'm leaving this, it'll start oscillating, and see how fast it oscillates. Okay, now going to the slow oscillation. Because we are beginning, we need to go slow, then later on we can put the mode to normal. So here I set my angle, and please make a note of the time taken to complete one oscillation. Write down experiment number and write down the time taken in seconds. Okay, so I'm releasing it, and the moment this pendulum crosses the reference line, I'm going to start my stopwatch, and I'm not good at that. Okay, so I'm just telling you there'll be errors in the readings. Okay, there, it didn't start. There was some technical snag, I guess. Okay, I'm resetting it. Again, I'll oscillate. Okay. Okay. Now when I say one oscillation means one oscillation got completed. Now you know it is not one oscillation. This completes one oscillation. So one, 2. So the second oscillation got completed. Now don't look at the blue lines, they'll misguide you. Okay, that was only for the first time. So 2 are completed. 3. 4. 5. 6. 7. 8. 9. 10. So for 10 oscillations, it took how much time? It took 17.99 seconds. So let's make a note of it somewhere. Okay. So that's 10 oscillations and 17.99 seconds. Okay. So now what is one oscillation equal to? How much is one oscillation? It's 17.99 divided by 10, which is 1.799. So around 1.7, you can say 1.8 around. If I don't approximate it, let it be additionally whatever it is. So time period according to this set of 10 oscillations is 1.799. Okay. Now let us time for one oscillation. Okay. Eventually what we did is we timed 10 oscillations and divided this 17.99 by 10. Now we took a larger number of oscillations because had I taken just one oscillation, it would have been very quick, meaning the time to start the stopwatch and the time to stop the stopwatch. The time difference between these two events would have been very small, so chances of inaccuracy would have increased. Okay. Still, I'll try to take only one reading, meaning I'll try to find the time taken for one oscillation, right? I'm resetting my stopwatch to 0 and this is my pendulum. I'll again put it back to 60 and let us see how much time it will take for one oscillation to be completed. Okay, there the watch started and this completes half an oscillation, and with this one oscillation is complete. So 1.80, while close enough, that's very close enough. Okay. You know why I'm so accurate? Maybe my 10, like when I took a set of 10 readings and divided by 10, I got 1.7999 something. If you round it off, it becomes 1.8. And here again, I got the time for one oscillation as again 1.8. I'm so close enough because probably I'm actually viewing perpendicular to the plane of oscillation and right in front of the marker or the pointer, that blue dotted line. That is one thing. Apart from that, also the oscillation is very slow. But had I timed myself for the normal oscillations, definitely I would have made an error, a larger error. The reason being that the time period between switching on the stopwatch and switching off the stopwatch would have been very small. So ideally it is advisable to time large number of oscillations, for example 10 oscillations, 20 oscillations, and that's what your paper 6 will be asking you. Like, why do you take 20 oscillations, they'll be asking you. The only idea is when you take large number of oscillations and when you find the average, you're actually getting answers which are accurate as possible. Like timing one oscillation will have more errors compared to timing 10 oscillations, right? Okay, so that's all in this video on calculating the period of a simple pendulum. And if you liked watching my video, please do subscribe to my channel. Thank you.